Hello, everyone. So welcome to the lab of week 6. Now, first of all, I'd like to demonstrate some of the ideas. Then I'll jump to the lab tutorial thing, and then I'll show you the task for the lab work for this week. Now, for example, ring is a Boolean value, Boolean variable, which is true. Now, if ring, then print the three dot that we discussed today in the lecture. If there is a three single quote, then it will we can do the multiple lines here, right? Ding dong. So there is a white space. So if I run it, I can see that the space is there. So if you want to omit that space, and then if you just run it, then you cannot see any space. Now the second example is, so this is string literal, star was 2, for example, and then I can use the third bracket to check the index. So the first one is the 0. So if I run it, I can see that the first character S is printed, right? And then the last one is -1. I can expect to get 2, right, using that. So if I do the -2, then this is this white space, right? I can expect nothing to be printed, which is the white space. But if I put the -3, then this is the S. So the last one is -1, then -2, -3, -4, -5, -6. This is how it works. So if -3, then I can see the S. This is this particular S, right? Similarly, if I do the 3, which is actually 0, 1, 2, 3, I can expect R. This is what I'm expecting. Now, the third example was like in the vowels. For example, these are the vowels, and I'm taking some input from the user, and I'm doing the for loop, like for vowel in vowels. S.S replace vowel with nothing, empty string. So any of these occurrence within the text that I'm giving the input would be deleted, would be replaced by empty string, including the white space. So if I just run it, and then suppose a fox is running. So if I type it, I can see this is the output. So any vowel, A, I, U, all are deleted, right? Including the white space is deleted, right? So these are the first half of the lecture that was actually discussed. Now, I would like to open today's lab work, right? This is the copy. So yeah. So now, this is the first example in the string and text in week 6. Our lab tutorial is this first example exercise is the following multi-line output can be produced by a single line of code. Can you reproduce this sequence exactly as shown with only one call to the print function? You might need to refer at the skip sequences section of the notepad. So I want to print something like that. My dog's name is Fido, and he isn't very smart, right? He isn't very smart. So, so what is the solution, right? So in case of this printout, this kind of output, if you just try to compare here. So my dog's name is Fido. So I use the single quote here. Then for any single quote to print, I need a backslash. But for double quote, I don't need the backslash because the start and the end thing was single quote, right? And new line is N. N is the new line because after Fido, there is a new line, right? This is a new line. So I need the N, and he isn't very smart. So isn't, that is actually printed. Or if I use the double quote here, then for single quote, I don't need backslash. However, for Fido, like is a double quote, I need a backslash here in this case. And also new line is needed. So, so that is the idea, is that when I use the first and the last kind of enclosing thing with single quote, then if I want to use a single quote inside the string, I need to use a backslash. However, if I want to use a double quote inside that, then I don't need backslash. On the other hand, if I use the enclosing thing with double quote, then in order to print another double quote, I need to use the backslash, but in order to print a single quote, I don't need any backslash. Now, the second example is actually name generator. So for example, John Smith, I want to print John underscore Smith. So any name, any white space would be replaced by underscore. So for example, you have to write a function to do that, like username from name. If I call with the name, then Alice Adams, if I put into the name Alice Adams, if I pass this name as a parameter of this function, so this function will replace the white space with a underscore character, right? So the solution is that I need to use the define function, and this is the function name, full name. So full name lower dot replace the space with a backslash, right? I think makes sense, right? So if I use the replace with a backslash, then that will basically run, right? So anyway, so this is the okay. So just one thing. So we could just do it here. So this is what is actually happening, right? So any name, it just make something like that. So it will just replace by something. Okay, good. Now the third example is that a better way to suggest a username might be to extract the part of the email address. So if you have an email address, then from the email address, anything before @ of is actually the name, right? And so on. Okay. So for example, write your username from email. So alice.a.au Gmail username from email. So before AU, you have to pick everything, right? So this is what is actually happening. So in the define function email, you get the email and find up to that point. So with the find, actually, you are getting the index of where the @ of starts, right? So in the email, from the starting point till at index, that value convert to the lower, right? So if I just copy that, simply typing here, right? Okay. It's executed, and this one is executed, and then I can see that I can pick the the name from the email address, right? This is the slicing. Okay, so I'll be back with that. Okay, now the next example is write a function below print receipt line, which prints a single line for a receipt using f strings. It should take as arguments for the item name and price and print it formatted as below. Note that 2 decimal places are printed even if it is a whole dollar amount, like frozen peas, 500 gram, $2. You may wish to refer to the workbook. Okay, now, so write or print a receipt function, and you can call this function using this way, right? So when you put that thing, these two parameters, it will print similar to this structure, right? Yeah. Okay, so what you can really do here is that you can print receipt line, name and price. You can take these two parameters. Now, in FE string, you can simply print the name, like the rice. If you can compare this output, like this is the name of the product, and then this is the name of the product is actually the whole thing, and then $2. So price, and there is a two numbers after the decimal points, right? So well, this is the format specifier. So two decimal places, 0.2f. Therefore, the price, and then this is the format specifier, is 0.2f. This is a floating number. If you do that, then which means that we are printing the price in this manner. So if I just run it, and then if we call this function, then I can see the output, right? So you can see that how, in which sequence we just ran the program, right? So this is what. Now, one of the problem here, not problem, I mean, it's one of the kind of probably requirement would be that why don't we make it kind of, alignment right? This alignment, I mean, one of the idea is that alignment can be like that. This is a kind of improved alignment thing. Now, we remember from our discussion in the lecture, during the lecture about the formatting, I'd probably like to open the formatting to revise that particular idea. I'm just opening the screen. We actually went through the alignment thing in depth during the lecture. So please refer to the lecture, but I'm just sort of revising some of the few points from the lecture very quickly. So in case of kind of floating points, suppose if I wanted to point 3f, like x is the number that I want to print using this format specifier. So after decimal point, it's a 3 decimal points, right? Three decimal digits. So if I do it, it will be 667, right? And 0f means after decimal point, there is no number, which means that this number would be rounded to 1. 0.6f means after decimal point, there would be 6 numbers. So 6 numbers, but there are 4 numbers. So the remaining 2 would be trailed with added trailing number, which is 0. That can be added. Okay. And the next one is the D. So D is used for the whole numbers. So 6D and 1, 2, 3, 6D. So 1, 2, 3, 6D, then you can see that I need 6 numbers, but minimum 3 numbers, but it is actually right aligned. So this alignment is really important if you can remember that example that we are trying to understand about the alignment. So in case of whole numbers, it is always right aligned. Okay, so that is one of the important thing here. Now, if we go to the string, there is a notation of a string here. In case of a string, what happens is that suppose hello, if I want to print using 8s, so definitely there are only 5. So 3 additional spaces I need, right? And this string is always left aligned. So what is the conclusion? That the string is left aligned, but the whole numbers are right aligned, right? However, I can change the alignment. So in order to change the alignment, I can use the greater than or smaller than sign. So for example, for the string, if I use greater than sign, it will be right aligned. But by default, it is left aligned. So if you see for the first example, hello, and then there are 3 spaces on the right side. But when I use the greater than sign, it becomes hello on the right side, which is the right aligned, and the 3 spaces at the left is empty. In case of digit, by default, it is, we know that right aligned, right? So empty space is here, but if I use the smaller than sign, then it becomes to the left and the empty spaces are up there. So if we have that in mind, this particular discussion, then actually it would be easier for us to look at our lab tutorial. So if I jump to the lab tutorial, so here we can see that if you try to compare the output at the beginning, it was, like this way, but now it is actually this way. So note the left items are left aligned. So left items are left aligned string. So the colons align with a width of 20 characters. So if I give a width of 20 characters, then definitely you can expect like that, right? And this one is a long string, which means that only minimum spaces are there remaining, right? Okay, so this is the output. So for example, the name, right? And no, sorry, the solution is there. That for the name, I need 20s, and for the price, 5.2F. So 5.2F means that after, in total, there are 5 digit can be placed, right? But 5.2 means after two decimal digits, right? Two decimal digits, and the remaining 3 should be on the left. But in case of 3, the 32, so including decimal digits, total 5. So there should be 2 more here, right? So 2 more, so 2 here. And since the numbers by default it is, we know that right aligned, right? Therefore, the space is automatically here. So after the $sign, there is a 1 space. But since it is 5.2, which means total 5 numbers and 2 decimal digits. So 2 decimal digits and then the 5 numbers. So this is the maximum possible thing. And the other things are kind of right aligned. So there is a space here, right? Right. So if I just do the run here using this function, and then if I just call it here, I can see okay, sorry. No, because this is the thing. Sorry. So this is the solution, or what I can do. And now if I type in, I can see the formatted output like this, right? Okay, now there is a file operation thing I would like to demonstrate now. Okay, so if I go to here, okay, now I'd like to show kind of file operation. Now, in case of file operation in Colab, what we need to do, if you look at the screen, so yep, on the leftmost side, I can click this icon, which is the files. If I click that, then I can see my files. So you can right click here to create your new file. You can create new folder, you can upload, you can refresh. Sometimes you create the file, it will be reflected here, right? So now, first thing is that you need to know the path of your file. So first is I create the colors to text file. So for example, the file is here. So if I double click it on the right side, I can see the content of the file here, right? Okay, so if I see here, click here and then click the copy path and can paste here, then you can see this is the path of your file, right? Okay, so if this is the path, so if this is the path of the file, then I can simply click the fopen and content colors.txt and then printf, right? It can be printed. Okay, so I'm just recording the lab thing. So later I'll upload that file, right? Yeah. Okay. Any question you can ask me in the chat. Okay. Now, again, on the left side, I can look at the content of the file. I can look at the path of the file by here, and then I can open the file. Or I can open the file from here, right? So I can put content colors.txt. I can click the printf. Then I can see the type of the file. Okay. Now another thing is that if I want to read the file, I can use the read command. So if I click that, I can see the content of the file, which is exactly similar of the text file format, right? Okay. Now, one of the thing that we all discussed that during the lecture. I'll upload the lecture file, but okay, not this one. So another example, if I would like to show here, is that suppose this is a file. I want to read line by line. So I'm opening the file here, and then I'm printing that dotted line, and then for line in file. So when line in file using the for loop, what happens is that it will scan each line from the file and process it individually, right? It's a very convenient way to read this. So the line holds the first line, and then I'm printing the line, so it will be printed. Now, why the white space is there? Because if I look at the file, which is the colors.txt, I can see that there's a new line definitely here, right? So in order to delete that new line, what I can do, I can put quotation and -1. So when I do the quotation -1, which means that the last line, sorry, the last character, which is the new line, will be excluded, right? So if I just run it, I can see that there is no gap here, right? All the new lines are printed. Okay. So this is the only thing that if you want to delete the last character, you can do that by this way, by this kind of indexing methods. Now, the second example of the file operation is that write mode. So if I use the write mode, if I open a file in write mode, what happens is that if the file is there, it will be deleted completely, and a new file in the same name will be created, and it will write the content again, right? Which means that it is a kind of destructive way to create a new file. So the old contents will be deleted in write mode. So I'm opening this. So for example, if I run it, for example, before running it, I just explained quickly that I'm opening the file in write mode. So which means any name of this file will be deleted. And then I'm writing into the file with the first line with a new line. A gift is nice, but two gifts are better. A new line and F close. So when I do the F close, all the content will be written, right? So what is the content of the gives.txt file? So if I look at it here, so already the text is there, right? Now I can probably, I can, sorry. I can probably do something here. I mean, just to define that I did some changes here. So if I do run it again, then I click this gives.txt, then I can see the new content of the file with our changes. So the old contents are gone, right? With the write mode. Okay, so that is one thing. Now, there's another option that if I open the file in append mode, then all the existing content will stay, but also the new content will be written at the end, right? That is actually expected in most cases. For example, if I think of kind of network log system or operating system log system in which we want to record whatever is happening, chronologically over time, then I need to open the file in append mode. There's going on to be more content on coding. How for this mix content? Sorry, I didn't understand. Is there going to be more content? Oh, I see. Yeah. No, Coding Hub is other people are managing it. So I think from this week, if you get more contents later on, I'm not sure about the Coding Hub, but in our lecture, the lab content, we'll just try to follow that. And that should be sufficient. So the lecture and, that should, is it okay, Lou? Yeah. Okay. I know Coding Hub is really, really useful, but I didn't find that because other people are managing it. So I'll notify that if I get any update there. Okay. Now, I just go back to these append mode thing. Now, there is a, if we try to understand this code that enter work completed and then input. So this input is asked for input, and then whatever input I'm getting, it is actually in work variable. And then I'm opening the file, the log text file in the append mode, and then I type into the the added thing into the right, and then I close the file, right? So there is already an existing file which is work log. So if I click it, I can see that 2, 3, 4 these lines are already there. So if I open this file, then I expect that the contents will stay, right? So if I run it, then I just try to add my new work 9, for example. So if I click it, then actually it's here, but I just click it again, the work log, then you can see that the new line is added due to the append mode, right? So this is what is really, the append mode is. Now the next example is the import OS thing. OS is a kind of module in which there are a lot of functions can be done. And in case of file operations, or OS modules. I mean, I'm just trying to check in ChatGPT. We just did that about the OS. So I just type file system operations reference table. Then I can see all the path names with examples, right? That can be done using the OS thing. Each and every one you can actually explain. You can actually look at the examples, how they can be demonstrated and so on. So that only 2 of the functions are used here in order to identify which is the path and which is the directory inside your program, right? So if I just say with this particular data, that is actually, in my case, it is already a folder. I can see that. So I just copy it. So it's a comment. So I just run it and it is taking input. If I just do the sample data folder, if I type it, it is saying that it's a directory, right? But if I type the table.txt, it should be, say, content, and then table.txt, then it is a file, right? And if I do something which is not there, right, then it will say that doesn't exist, right? So this program is working this way using these 2 functions. OS path is file and OS path is directory. So is file, anything with is actually a Boolean. It returns a Boolean value. Is directory means is it a directory or not? Is file means is it a file or not, right? And so on. Okay. Now, the last thing probably would be our binary conversion thing. So this is the week 6 lab. But before starting it, I just need to give a quick break, just 2 minutes break. Okay. Now, this week's lab is it's binary conversion table that uses the formatting options. The formatting options at the same time it uses the file operations, right? So the formatting options inside the if string or whatever you can think of. Okay. So in everyday life, we represent numbers in decimal using 0, 1, 2, and 9. On the other hand, computers often represent numbers in binary, right? 1 and 0. So for example, 0, 0, 0, 0 is 0, right? 1 is, so this is the binary number, and this is the corresponding decimal number. So 3 is the decimal number. Its binary representation is 0, 0, 0, 0, and 1, 1, right? Write a program which saves a binary conversion table like this that shows above to a file called table.txt. The program accepts two integers as input. The starting number is start and the stopping number is stop. The binary conversion table should have a row for each integer I, starting from start and going up to, but not including stop. The above output is for when start equal to 0 and stop equal to 4. So stop equal to 4, so it went up to stop minus 1, which is 3, right? Note that the binary number should have leading zeros in to ensure that at least 8-digit wide. So it must be at least 8-digit. That's why we have many 0 at the beginning, right? Which makes sense. Now, the easiest way to construct the rows of that output table is to use a f string, in which we can use the format specifier, right? We can use the format specifier, right? Okay, we'll look at very simple example, then it would be absolutely clear, right? The easiest way to construct the rows of each output is a string to form each content. There is a B presentation type which displays an integer in binary, like D displays an integer decimal. So for example, I just want to jump here in the hints, for example, that if I put print f xb, then the number x would be represented by binary number. So it outputs 100, which is 4 in binary. So if x equal to 4, then this printout will give binary 100, right? So this is an interesting thing here. Now, I would like to demonstrate that in a simple way. Yeah, sorry. So for example, okay, so we can see here that printf two, and then suppose if I use, I mean, 0 and then 5, which means that 5 is space. So if I run it, then the 2 is a decimal number, which is 10. That is represented by the 5 numbers, 5 digits, right? So if I make it 12, the 12 digit, it will be in total 12 digit, right? And the starting 0 is that actually at the beginning, the 0 must be there. Okay, now that is how the systems are working here. Now, if I go back to okay, sorry, in the binary conversion table. So, like for example, here print xd or x03d, that will output 4, 004. So 0003 means 004, right? In decimal number. But we need the binary because we are transferring to binary. Now, another point is here, for example, that the 42, if I use 04d, then it will be printed 0042. Total 4 numbers, right? And starting with the 0 at the beginning, then 42. So instead of this, right, there is no spaces there. So if I don't use 0, then we can see that empty space would be there. So the same principle we can apply for, the 8 kind of thing, the 8-digit thing that we are discussing. So now look at this problem, what we need to do. So start int import start. So in that case, we can ask a number. What is the starting number? It may be 0 or 1 or 2, whatever. And stop is the n number, which is 6, 7, 8, or whatever. So if I put 0 to 5, it will be printed from 0 to 3. 0 to 4, right? Now I need to make a function here. So this function is actually a binary conversion number. And then I need to do the conversion thing, right? Okay, so just one thing here. So it is like, um, just, okay, so for example, the code is entered the starting number. So if you look at here, that enter the starting number. So definitely it is using the input and enter the stopping number. Then probably the start you can take into this way and then save the binary conversion number from start to stop. So in this particular function, you have to define this function at the top here, in which from start to end number you need to transform. Now, if the start is, for example, 2, so look at this here. So I can probably use the 8, right? So if I put 8, then I can expect the printout like that, right? Then from start, I'm starting. So if the second number is 3, so I can use a for loop, right? Here I can use basically a for loop to print all these numbers, right? So just give me a sec. I'm trying to. Okay. Um, okay, so I mean, if I just, for example, do it here, that for I in range, right? In range, we start and end, right? And end, and then the print, right? Which is the I, right? And then, so you can just try to think that if you start equal to 1 and end equal to 5, right? So you can expect a printout like that, right? Of course, you have to print the I as well, right? This is the I conversion. So you can imagine that. So this is what we are expecting. So I just gave, kind of partial code. So you have to get the output, and then actually after the for loop, so during the for loop, basically here you have to do a file operation. So you have to add to a file, right? To a file. Every line you have to add to a file, which means that the file must be opened. Open the file, sorry, in append mode, right? So then actually you can actually, do the thing. Basically, you can basically do the thing, right? So this is what is actually the program is. Now, if we go back to the binary conversion thing here, yep, this is what is actually expected. So you can see that I am taking the start as the input parameter and stop, and then I showed you the code just then, and then you can put the function here, and then you can call the function using start and end, and then you can write, you can append every content of the binary conversion there. And finally, once everything is written, you can open the file. The code is already given here, and then you can print the content of the file, right? Any question you can ask me. I think this is what the expected thing is. So again, if I just go back here, I showed you the I mean, if I just try to relate these two things, that would be easier. Some question came about that, that this the start is given, stop is given, right? Then I'm calling this using, you don't need the value. You just use the call. So using a defined function, inside a function, you just do this type of thing, right? So you can put the range, you can do the printout, and you can append to the file. And then you just show the content of the file. This is what you basically need to do. So it's really easy, and it should be, it should be easy basically to finish. And 8-bit, this is what, if you look at the content, this is what so this is 0. So which means that our format needs to be slightly modified. Is that, of course, I mean, to modify that. So this is this, right? This is what we're trying to output. So this is what we have to do the output, right? But you have to add that file to a file. So I think that's it. It should be easy to do, right? Any question, please shoot me an email and we can do a Zoom meeting any day after 6 o'clock. It should be fine. If you need any help, you can shoot me an email, right? Or you can email me. I can help you on that. Okay, take care, all of you. Any question? Otherwise, I can finish the class. Okay. Okay, thank you all. And see you next class on Wednesday. So next regular class would be on Wednesday. Yeah, thank you.